Everyone, sorry for the technical difficulties. I think we're all used to that by now. Thank you so much. Thanks for your help. Thanks for attending the workshop, day 2 of API Days. Thanks for sticking around for the best workshop, saving for the last. I'm trying to make this more interactive, especially later in the day after lunch, and not just have me speak or in 50 minutes, kind of hard to do a workshop, and how are you guys going to be following along? So I made it a combination of a couple of slides, not that many. I will also show you a link to a full workshop that we actually do. It's almost like an hour and a half long. So I won't be able to do justice to it, but I will be covering a big chunk of it. And this one, hopefully piquing your interest in following the extended version later on. So I have some questions for you guys. Who here uses real-time messaging in their day-to-day job right now? Okay, 2 people. All right, 3. Okay, cool. That's good to know. So in today's session, which I have only 30 minutes left now to do, we'll be talking about a little bit about EDA, Event-Driven Architecture. That's something that I focus on mainly in my job right now. We'll talk about key components of what comes with an event-driven architecture. Some of these you're going to be familiar with because the inspiration of these components is the whole API landscape, which is more mature as a umbrella term than the asynchronous APIs that we will be focusing on today. And then walk through these different components. I'll do a live interactive demo of that. So event-driven architecture, it is quite a buzzword out there. It's been there for a while. It is becoming more tangible, more realistic in the recent times, especially due to COVID. So we're seeing a lot more real applications of this type of architecture recently, but it is being used in different ways. And these are kind of the problems that I work with my clients in my day-to-day job to address. And there are a bunch of them, right? So when I'm talking to people about event-driven architecture or what we do, I try to narrow down on which of these topics is it going to resonate with them the most. So first of all, the need for real-time, that's the main one. Moving away or complementing your synchronous APIs, poll-based approach, batch processing with real-time messaging, that is the main one. So if you were here yesterday for the keynote, I mentioned then that the clients that I focus on mostly as a solutions architect is financial markets. So capital markets, especially financial services. And over there, they have been dealing with real-time data for decades now, right? So the idea of stock prices moving and you doing something with those updates as they're coming in real time. And over time, they've gone from minutely data to millisecond or seconds, milliseconds, and now nanoseconds. So the latency numbers that we talk about there, what real time means in capital markets is very different from a retailer, say Walmart or Edeka in Europe or IKEA. What it means to be real time in that space in retail market, very different from a different industry like capital markets. So I try to understand what does real time mean to different people in their industries. From an architecture perspective, moving away from monolithic application, this is quite a wide trend. As you migrate to the cloud, which is the third one, you're moving away from a giant monolithic application running maybe on a mainframe to more smaller microservices leveraging cloud native services. And how do you make sure now that they can talk to each other? So before you had one giant application that you would deploy, it doesn't need to talk to too many different components. But now you have multiple services. They might not even be deployed on the same cloud provider. They might be using different types of platforms. So how can they talk to each other without being tightly coupled? Migration to the cloud, a lot of companies, especially bigger companies in highly regulated industries, are now in sort of a hybrid phase, right? So they have agreed on the fact that, yes, we do need to move to the cloud. So they took several years to even decide that. And they've had partnerships with GCP, AWS, or Azure. We're moving to the cloud. But actually, they're moving the components that are the less riskiest, right? So they're some logging applications or shipping their logging data. So just to test the environment to see how safe is it, are they going to get it right or not? So what you see is this hybrid model right now where you have on-prem application is slowly migrating to the cloud. So they have to maintain both environments. And how can you share the data in real time between the two environments? Another approach to this is we're starting to see is multi-cloud. People are saying, why should I only rely on one cloud? If AWS goes down, a bunch of different websites, half of the internet is down, right? So how can I mitigate that risk that if I'm a bank and AWS is down, how easily can I fail over to GCP or Azure or vice versa? So we're seeing this on-prem because your core banking services, let's say, would be on-prem for the most part. Then within the different cloud providers, they're picking more than one. The other idea is also that why do I need to pick one cloud provider and just go with everything that they offer? Maybe I'll pick by the services. So maybe AWS has a really good machine learning platform. GCP has BigQuery. Maybe I like to use BigQuery instead. So how can I use the services that each cloud provider is known for, is excelling in, rather than committing to their entire ecosystem? Deep coupling your applications, so adopting EDA so that you can be more agile. You can then modify a small component of your application without impacting everything else. And you don't have to worry about what someone did 5 years ago at your company, and that if you change something in your code, it might impact a piece of code that you didn't even existed, or some application that you didn't know existed. Scaling is a big factor, especially if you're a small startup, you're starting up. As your code gets more and more complicated, how easily can you scale based on your consumer demands? And finally, multiple protocols and API support. So it goes back to the kind of decoupling factor where you don't want to be tied down to a vendor, a specific API, specific protocol. So how can you have a platform ecosystem where you can kind of pick and choose the different messaging protocols? So these are the different topics I usually talk to my clients about, and then I'll be focused on the solution. So this is PubSub. Event-driven architecture is a big umbrella term. The main part of it is PubSub communication. So when you're starting up, you'll do something like this where you have different publishers, different subscribers, and you'll do one-to-one integrations. A lot of this would be based on RESTful APIs, and it's a totally fine way to do it when you're starting up. Why invest in a very complicated solution and over-engineer things when you don't need to? But as you're working on these interactions or integrations, you start seeing that every time you need to change one service, you then have to change all of these integrations, right? So you want to put something in middle. You also want to move away from synchronous calls unless you need them. So I'm not advocating for removing everything that's synchronous. I believe in a hybrid architecture. A very common example is payments architecture, where when you buy something, there's a lot of different steps behind the scenes that happen. So when you tap your credit card, there's authentication, validation, funding, fraud detection that happens, on visas, railways, or whoever's the payment provider is. API gateways, payment gateways. So not all of them have to be synchronous calls, because if they're synchronous, then the requester is waiting for those that response to be provided, right? And that's going to have a cascading effect. So if you have 5 different responses that you're waiting for, it's going to add up. So what you can do is you can have a hybrid architecture where authentication is a very important step. You don't want to do anything else until you confirm that this person or this card is where you expect it to be, right? If you're buying something from Amazon, they would like you to verify that you are who you say you are and your card is valid before you actually purchase something. However, the rest of the steps in the whole sequence of steps can be orchestrated so that they're not synchronous calls. So you can have a bunch of synchronous calls, RESTful endpoints, but maybe the 3-4 next steps could be fraud detection. Maybe you don't need to do fraud detection for small transactions right away. Right? If you're buying something for $50, you would rather provide a better experience to a bunch of clients and take the risk of, okay, maybe 1 or 2 would be fraudulent activities, and which I will act on later on. Or you have maybe reporting application that, okay, you know what, I don't need to do everything right now. I will listen to the messages and I will send a response back later on when it is okay to do so. So that's where event-driven architecture comes into play. I also talked about the decoupling from a protocol perspective. So this is where there are a lot of different messaging protocols. New ones keep coming out. So I work for a company called Solace. We have our own native protocol called Solace Messaging Format. However, there are a bunch of other ones that we support, such as HTTP, of course. AMQP is a real-time one. MQTT is an open protocol as well, which is very common for IoT devices. So if you like to dive into that, this is basically the de facto standard. Then there is WebSockets as well. So if you're working on web dashboards, stuff, and REST, of course. So when you put something like a middleware layer, a messaging broker in between that can support these protocols, what it allows you to do is, and this is really useful in a big organization, is that you can have a team that is, let's say, using AMQP. They decided that for their use case, AMQP messaging protocol is the best, and they will use whatever APIs supports AMQP. So Apache has a bunch of APIs for AMQP because it's an open protocol. Another team might use MQTT. So let's say a payment company, right? So they might have a backend service using Java and JMS. They might have actual devices, payment devices, POSs, which might use MQTT to send messages back to their servers. So you might use a C API on top of that. On the other side, that side doesn't need to know anything about what this side is doing. They don't need to care whether the message is coming through MQTT, AMQP, HTTP, or SMF. They look at what their requirements are and they say, you know what, I'm a dashboard application. I'm going to use WebSockets for streaming real-time data to my end users, and I'm going to use JavaScript for that. Totally can do that. The middleware layer will do the messaging protocol translation, will provide these APIs to you, and you will rely on those. You can use, let's say the company's protocol is SMF. You can use GMS for that. So you might have an application that is using GMS already with another broker that supports GMS. And you say, I don't want to change my code. I just want to change the host and port and connect to a different broker, and I will use GMS instead. So over time, what it does is allows you to change these easily without impacting any other components. So I can move away from, let's say, RESTful API if I wanted to, and pick Python and AMQP tomorrow, and I don't need to change anything on this side. What it also does is you only publish the data once. So the point of PubSub is that publish once, subscribe n number of times. So if I'm publishing data today, if I'm a stock market application, let's say Robinhood, I'm publishing stock market prices. I might have an order application, order managing system. I might have an execution management system. I might have a P&L application. I might have a reporting application that all rely on that data, but I would prefer to only send that data once and then fan it out to these 4 different applications. Tomorrow, I might have 10 other applications as Robinhood scales and becomes bigger, right? As I add a crypto component to it, I might start publishing crypto data, and I have a whole crypto set of applications on the other end. But I don't want this side to change, and that's what PubSub architecture does. Any questions so far? All right. So this is the code lab that I would have loved to do in this session. This takes much longer, but it is very detailed. It does go through the theory that I'm talking about right now and even more. It paints a nice use case for you. I think it's the New York Taxi famous data set that it works with. And it shows you how you can build these applications, design this architecture in a nice governed way, add a schema to it, topics and all that stuff. Like I said before, the API, the synchronous API landscape is quite mature, has been there for several years now. There's a lot of governance tools, a lot of vendors outside that provide these monitoring tool, governance tools, security tools on top of your endpoints. That is not the case with asynchronous communication. There is a standard that has come out recently, and we contribute to that as well, called Async API. You'll be hearing about it a lot more as this space matures, as more and more industries start adopting this. And this is why we are taking a step as a company to provide more tooling to the governance layer of it. Because we saw that our clients who are building these applications, you start publishing a lot of data, start subscribing to a lot of data, but you don't know, like 10 years later or 5 years later, you don't know what's actually happening in the runtime. You don't know what topics you're publishing data to, who's publishing what data, what schemas they're publishing data to. If I'm a new developer in this giant bank, which team do I reach out to get access to this data? What data is available to me as well? So we are helping provide that tooling, because right now, like most companies are using Excel or static wiki pages to document that, which, as we know, the next day they become outdated. So how do you manage that? So I was hoping this would be an interactive workshop, but since it's not, this is the event portal that you would sign up for to do the lab. This, I think, has a 60-day or 90-day free trial to try out. But I would like to show you what that actually looks like. So if you want to scan that, go ahead. Yes. Yes, yeah. So a big value proposition is to not go with a hyperscaler for their messaging format. People ask me, like, why can't I use SQS, SNS, Event Hub, right? The idea is, like I said, companies moving to a hybrid cloud and a multi-cloud environment, which you can't do with SQS. You can't do that. And you also don't want to be tied to, messaging is like your central nervous system. All of your applications will be using this central layer of message distribution to connect to and share data with each other. If you end up relying on a hyperscaler, it makes it extremely difficult for you to then jump on to another one tomorrow or leverage a different service. So that's our value proposition, that you can deploy us actually as a hardware as well. So I know hardware is not very popular these days, but investment banks do love to use the hardware because it's very cost efficient and provides high throughput and low latency. Actually, nanoseconds. So like, sorry, no, not nanoseconds, what I'm saying, microseconds. 18 microseconds is the latency that we can hit. Sorry? No, Edge, I would say, like, has a smaller footprint. This is like a proper appliance that goes into your data center. It's for like very, very highly efficient use cases, like market data distribution, where you're sending millions of messages per second. For other use cases, the software is very common. So you can deploy our brokers, download them as a Docker container. Standard edition is available for free in production as well. And it's capped at 10,000 messages per second, which for many industries that other industries that I talk to, like retail, that's more than enough, 10,000 messages per second, right? So you can use that in production as well for free. Then the next phase that we did was the last 3 years is the building a whole platform around it. So before we were just selling the brokers, we saw that there was the need for this governance layer, and we came up with event portal and monitoring, and we provided this as a managed service through Solace Cloud. So when you sign up for this, you're signing up for Solace Cloud, and one of the features is event portal. But you can also deploy a broker very easily in AWS, GCP, or Azure. You can connect them together, so now you can share data between AWS and GCP. You can monitor everything in one go. So let me show you what that looks like. How are we doing on time? So this is the portal, and like I said, it has multiple components to it. So event management is the latest one that we added. This is the governance part of it. So design time, and then this is the runtime where the actual broker is deployed. So this will allow you to spin up a new service, spin it down with high availability. This allows you to connect those services from AWS to GCP, like single click. And then there's the monitoring part, which basically uses Datadog under the hood. But today we will focus on the governance part of it. So there are 4 components. Inspiration is API portal. That's why we call it event portal. So there's the designer, which is the UI component. So visually be able to design that these are my applications. They're sharing these events and be able to see that, so that if I change something on this application, which are the 5 different downstream applications that will be impacted, and then I'll have to contact them. Everything that you create here will be saved in the catalog. So this is extremely popular. People ask us, do you have a cataloging solution for my events? So if I'm going to adopt event-driven architecture and publish all these events, how do I govern that? How do I know how to find them? So everything that you will create, all the objects here, will be saved into this database, and we have a nice search layer on top of it, and that's what the catalog is. But then people come and say, okay, that sounds great in an ideal world. Architects will sit down and they'll design this architecture. They'll tell the developers to write the code, and it will go into production. Great. But obviously, that's not what happens. People do their own thing. Many people will start with the runtime. They're like, we should probably catalog this. So how do you go back? How do you go from designer to runtime, but then the other way as well? And that's where discovery comes in. Currently, as it is right now, in Event Portal, this is 1.0. 2.0 is coming soon. Right now, what you can do is run jobs as a container, which will go and scan your brokers and say, these are the messages that are going through your broker at any given time. These are the topics you're publishing to. And then you will be able to pull that information. It dumps a YAML file. You can upload that into the designer and then go back to the design phase and put that into catalog. So it goes both ways. What we're doing right now is making it more real time in the sense that you can always have a process running that is scanning your runtime, and auditing. So it's an ongoing thing, and you always know that, oh, this one application is not behaving the way it's supposed to according to the designer. Final component is Event API products. This came, if I remember correctly, my internal teams with a public-facing documentation, or I would like to monetize on that. So expose it to external developers and find a way to monetize it. So this is what that does. It allows you to productize your events that you are creating over here. So if I show you the designer, it's this one. Okay. So let's go to, so I'm going to delete this. So it's part of a different demo. So this is my favorite architecture because it relates to a previous role I had. So this is from a hedge fund, where you have a market data team that is capturing all this stock prices that I talked about earlier, and then you have a team that is calculating P&L. You have a risk team that is saying, you know what, you're heavily bought into Europe right now, East Europe, right? A lot of risk, geopolitical risk going on over there, so you should reduce your positions in Ukraine. So that would be the risk team subscribing to that data. Then you have a TCA team saying, as you buy too many securities, you're actually moving the market and you're getting a really, so don't buy stocks. And you might have a dashboard which is showing your P&L in real time because your CEO wants to see that on his iPad all the time. So this is where you would see that, okay, I have a market data team that is publishing 2 events. With this arrow, you can say that it's publishing that, and it is being subscribed by this tick data team. I also have 2 events coming out of market data, which is being subscribed to by a P&L team. So these are applications, and then these are events that have been grouped. So if I click here, I'll see that these are daily pricing data download event and market data updates event. So if I click on market data, and I will go. So this is a very consistent UI that you'll see. This is an event. You will see a similar UI if you were looking at an application. So this shows you, if I were to subscribe to this event, market data updates. Basically, this event is triggered when market data updates are received by the market data feed handlers. A little bit of technical jargon, but every time there's a price update, an update is published on this as part of this event. So, okay, all right, maybe I'm interested in data. Great. How do I get that data? So this is the topic. So I need to know what do I subscribe to actually get that data. So in our world, in Solace world, you have, and in RabbitMQ as well, and other brokers too, you have hierarchical topics. So these, each level describes something about the topic. So this is the trading application, market data, it's pricing data. Maybe I'll have V1 or V2 here. Data source can be whether it's Reuters or Bloomberg or something else. It's tick level data, so it's not aggregated data. And it's either equities, commodities, futures, options, whatever, and then maybe Apple as a symbol or IBM, right? So this is the kind of information I need to be able to subscribe to this data. And then you want to know what kind of schema it is. So what am I subscribing to and what will I get? So here you can see, in this case, just a simple JSON schema, and I can go look at the raw schema. So this will tell me what I need to, what I will be expecting when I do subscribe to this data. What you can also see here is that from an event perspective, I can see that there are 3 applications subscribing to it. So we saw the sort of the UI layer, that dependency, but here we can see that if I were to change anything with this event, there are these 3 downstream applications that rely on this event and they will break. So I should check with them when I make an update. The market data team is the one publishing this data. I also have all this metadata, and this is very common. I used to work at a bank before. A lot of people leave. A lot of applications stay for a long time. People don't want to touch them if everything is working fine. You would like to know who owns that today. Or you would like to know when was it last modified. Is anyone actually using it today? Should I be consuming from this event if it's orphan, no one's actually using it, no one has made any enhancements to it? Who should I contact to ask about that information? Who's the owner of this? That kind of information. And every time you make a revision to this information, you can look at the revision history as well and see, when was this last modified and what was the reason, what was modified last time. So all that information. You can also go to the catalog and say, I'm a developer, I would like pricing data. What is available to me? So the bigger the organization, the more value you get out of a product like this, right? Because there's more to search through. So say, I would like to get market data. And if I search for that, here are all the options I have. This is a shared account, so a lot of my colleagues have also created these demos. So you can see a lot of market data updates. And I have information around application domains. So maybe I'm part of the trade processing team, and this is the one that suits my needs most. Or this is the one that I was looking at earlier because I'm part of the trading system, middle office team, and this is what I would like to focus on. And you can see that this one has the most matches, right? So I wonder why this one didn't show up first. Anyways, so I can go back to that. So similarly, you can search across events, schemas, and applications. These are different objects in the UI that you can search across. Any questions so far?
Can I send document to the stream event?
Yes, you can. You can. We support up to, it depends on the broker that you're using, what's the maximum file size that it supports, right? So you can, if it doesn't support the size of the file, there's usually some logic for you to split up the file into smaller chunks and then build that again on the other side. We support up to 30 MBs. So I have 30 MB. So I've seen people do that. Yeah. So auto scale in that sense, no. I think you're talking more on the Kafka terms as having topic partitions. So in our world, topics are not. So Kafka, it's basically a distributed log system. So partitions are these files on your server, right? You can split them up for parallel processing, but you lose order in that case. So you can't have order across partitions. In our world, and some other brokers as well, topics are purely metadata that you attach to your payload. We also don't look at your payload. So we're payload agnostic, send whatever you want. You just send a string of data, the metadata, which is the topic. So you don't need to create any topic beforehand. You don't need to partition it. It is hierarchical, like I showed before. So you can filter on the consumer side. So you can say, give me only Apple's data or give me Nice's data, and we will just send that. Then we have queues as well. So Kafka only has topics. We have queues, and which is like classical queuing system, right? So you can map multiple topics to it and get order across those topics in that one queue. And queue will provide you with persistence. Yes. So we support 2 levels of quality of service. So the market data use case I talked about, there you're okay with losing some messages. But the real requirement is to get the messages as soon as possible. So speed is of the most importance. Then there's trade processing or order processing, order fulfillment, where you have lower throughput, but higher value data. So another example is like in payments, retail payments are, you and me swiping our cards. Not going to spend too much in a transaction, hopefully not. It's okay if you lose 1 data or two message points. If you have wholesale transactions, that's B2B, thousands of data, dollars, millions of dollars. Every message is important, but you're not going to have so many messages. In those use cases, you do want persistence. You want to make sure there's 0 message loss. So we do provide that, and you do that through acknowledgements. So publisher sends a message, broker acknowledges, okay, broker got it, broker will store it, consumer comes online, says I want that data is delivered, and then the consumer will acknowledge that data back, send an acknowledgement back to the broker. When that broker gets that acknowledgement, you will delete the data. And that's how you get end-to-end acknowledgements, yes.
How do you answer questions about security?
Each channel is encrypted, so security in motion, like in motion as opposed to security at rest. At rest, you just encrypt your disk. But in motion, TLS 1.1 is what we use to encrypt each channel. We support different authentication mechanism as well. But what's more common is, or more what people like to talk about is ACL profiles on limiting what topics you can publish to, on what topics you can subscribe to. You had a question.
From the sync API perspective,
yes.
Sync API specification perspective, where does it fit in here?
Very good question. I forgot to cover that. Yes, thank you so much. Good point.
Yeah, from this perspective,
yes.
Is that directly to the source?
Yes.
But I'm curious from the
very good question.
design perspective.
Yes. So yes. So the next part of this, okay, architect design all this. Okay, great. How can developers use this? So I talked about async API briefly. This is a new standard that's coming up. Not many people know about it, but it's still coming up, and I think it's going to be really popular. Really, there's no other alternative right now. It's a way for you to design a spec that works with different brokers. Right? And by the way, this tool works with different brokers as well. It works currently with Kafka and Solace. And the goal is to, we have open sourced the discovery part of it. So it will work with other products as well, such as IBM MQ and other brokers as well, because many companies do use different brokers. So in this use case, you just click here, download async API specs. So you have put all this metadata here, right? How can you make sure that you provide a standard way or standard spec for your developers to use this data and not do whatever they want and make mistakes for the runtime? So you download the async API spec from here because you have all this information, JSON or YAML, and then async API provides a lot of code generators, so in different languages for different tools. So then you feed in this spec, you use the generator that you need to use, and there it pops up some boilerplate code, and then you will add your business logic to it. Thank you so much. I forgot to cover that. Any other questions? Sorry? It's basically you put in the information like what do I need to subscribe to, which queue I need to bind to, or what topics I need to subscribe to. So it's providing a standard way for you to share that information because you might have some team using Kafka brokers, you might have another one using Solace or RabbitMQ. So how do you develop an API on top of that supports different brokers? So it provides that standardized spec on top of that. Marcus? Yeah, so I'll address that by two features. One is replay. So a common requirement is that you have two subscribers subscribing to the data, and the third one says, oops, actually I wanted yesterday's data, but I didn't subscribe to it. Can I still get it even after it has been consumed? And that's where message replay comes in. Say, okay, replay the data from yesterday, I would like to get it. Or an application is getting some data and then it crashes. It says, you know what, I would like to replay today's data again so I can reprocess it and persist it into some database layer or something. So we have replay for persistent messages that I talked about that you can turn on. The other one is it's coming out anytime now. It's available in early access mode. GA mode will be out soon. It's called distributed tracing. And it supports open standard, open telemetry, which you might have heard of in the observability space. So tracing is, especially with the cloud processes, the processes can go down a lot. How do you make sure that data that needs to go there is going there? Or someone coined the term mean time to innocence. So middleware team face this problem a lot where they say data was delivered to you, but the application team says, no, it wasn't. It's your problem. You're guilty. Prove that you're not guilty. You're innocent, right? So it's always up to the middleware team to prove that they're innocent. And so this tool will allow you to say, I talked about those acknowledgements from publisher to subscribe to broker, and then broker to subscriber and back. This tool will allow you to send events as the message moves from your application to the broker, to the queue, to the consumer, and that acknowledgement comes back. So you'll have an event that pops out and say, it was now sent to the broker, broker saved it, it was now delivered to the consumer, and consumer has acknowledged it. So you can go to your team and say, you acknowledged it at this specific time. Now it's up to you to tell me why that is not the case, why something went wrong on your side. And because we use the open telemetry open standard, you can then plug it in with other applications as well. So usually messages are going through different systems, right? It's not just one broker that you're using. You might be going through multiple brokers, or from IBM MQ, Data Power, to Solace, to Kafka, right? A bunch of different components, and then maybe some monitoring tool. So you want to be able to trace a message across these systems, and you want to use an open standard for that, and you can use open telemetry. How much time do I have? Any other questions? I have time. I can stay as long. Yes.
You were showing that you can like export the async API specification. Can you do it backwards, like from the specification, go to the kind of diagram design?
Good point. I don't believe yet in this tool that you can. I will check with our team whether you can do it the other way around. That's a good point. Do you work for Async API? Okay, yeah. Nice.
There are tools on that front.
Yeah.
I'm curious about on the Async API
Yeah.
specification front. What are the key questions?
Yeah, we are one of the contributors to Async API, so we can influence it. So I'll check with the team that, like, part of Solace team that works with Async API's team. So I'll check with that if that's part of the roadmap. Good point. Any other questions? Anyone finds this useful? Like, do you see using real-time messaging? So a common use case is what we call event mesh. Kind of came out of like service mesh, but the idea is you're gonna put brokers, smaller brokers, across maybe different vendors, AWS, GCP, Azure, different geographies, edge brokers, as well as your main data center brokers. So you can do that in different form factors. Maybe a bank says, I have this giant appliances that I'm using, but then I might have a software broker a little bit in one of my subsidiaries in Asia, right? Or I want to have something on the edge to reduce latency there, but then centralize core brokers somewhere else. So how do I share data across them? And how do I only share the data that needs to go there? So not blindly just copying all the topics from one environment to another, but only sending the data that needs to go there. And just a little bit of history, we're based in Canada, and we came out of like when networking equipments were becoming really popular in Canada. A lot of networking companies came out of that. So we're like, brokers are pretty much like network routers. And the way we distribute data is like we maintain a table of different topics, just kind of like IP addresses are maintained by your router, and you know which one to go to access a website. We send the data that needs to go there. So if you're sending all the market data for all exchanges in US onto these hardware, because that hardware can handle it, but you have one little microservice in Ireland in AWS that only wants Apple's data. Should I be sending all of that data only for you to discard it? No, right? That doesn't make sense, because one, you're wasting bandwidth. Two, AWS is going to charge you a lot of money to filter that data and then to discard it. Finally, if you want to move that data back, so you derive something out of it and you probably want to share that with other services, it's going to charge you a lot of money to do that too. So when you subscribe using wildcards to these topics, we will only send Apple's data to that microservice only when it needs it. So if it only works 1 hour a day to do whatever it needs to do, only for that 1 hour, that data is streaming automatically to AWS. When that application says, I don't need this subscription anymore, I'm shutting down, we remove that subscription from the list of subscriptions that we maintain, and that data stops flowing outside your environment. So from a security perspective too, if you're healthcare, insurance, clients, very sensitive data, you don't want to be sending that data to the cloud unless you have to. All right.
So,
yes.
I think there is forgive me if you answer this already.
Sure.
But how does these, your broker differ from traditional AMQP brokers?
So yeah, AMQP is a messaging protocol which we support as well. So a lot of the features.
How does it differ from
RabbitMQ, yes. So the clients that we talked to about RabbitMQ, they have issues with scaling and a lot with reliability. So this is when we start talking about HA, high availability and disaster recovery. So how reliably can you make sure that another broker is up to speed? So whether it's in 2 data centers or within a data center, high availability, or within a region in the cloud, having 2 availability zones, having brokers running there, and they're always in sync. So if one broker goes down, I can, within less than 30 seconds, fail over to the next broker and have all my configuration ready to go, as well as the messages. So, as if nothing went wrong. And then we talk about disaster recovery. So if a whole region fails or a whole data center goes offline, how easily can you switch over to a different data center without any issues? RabbitMQ, and Emily, you can correct me, I think with IBM MQ as well, the issues were that our clients have talked about around disaster recovery. So how long does it take for you to switch over to a different region? And that's where we come into the picture. But like the topic stuff that I talked about, Rabbit has that as well. AMQP messaging protocol has that as well. MQTT has that as well. And that's why we're able to support them, because the fundamental topic structure is the same between the brokers.
And I think the fundamental difference, as Himanshu mentioned, is that we came out of that network engineering space, so all of our founders came out of work on networks and building routers and switches. So the design of the message protocol itself is kind of a network up approach, and we built that application networking on top of application messaging on top of the layer 2, layer 3 part of the OSI stack. So it's built from a network perspective. So if you even look at the broker stats, we'll actually get a lot of details down to like, is that kind of experiencing message retransmits or time retransmits, things that will actually indicate network congestion, or does the IBM keys of the world, the Rabbit keys of the world, the academic keys of the world, we're built at that layer 7 part of the stack as an application perspective. And so that's where I think fundamentally why it has some challenges around things like the resiliency aspects.
Yeah.
Performance, and then also just even being able to do things like event measurement that brokers across different regions, different clouds, because we're at the network level, coming from that approach. All of that is actually happening over like intelligent battle protocols versus kind of trying to just connect over,
Yeah, so this is what the broker UI looks like. So if you go from the event portal to cluster manager, this is my service running in AWS. I open up the broker manager. So we provide, this is the UI that comes with the broker, even with the standard edition for free. It has all these, it has more stats that you know how to use. The challenge would be, which one do I care about? So at a service level, at clients level, you can see different protocols. So if I have an MQTT client, it will show up here. I don't have anything right now, but at each client level, you can see the different transactions that are going through, stats per client. And we have like TCP, these are TCP connections. So we have TCP level stats as well. We have the queues, example. So this is my NYSE queue where I'm using wildcard to say, give me all the data that's for NYSE. So I might be publishing data for NASDAQ, CME, but I only care about NYSE's data. And then access control. Here I can say, these are my ACL profile, and in this, I will only be allowed to subscribe to equities data. So I cannot subscribe to commodities or FX data. So this is from a security perspective. Yeah, I think we're over time. Thanks for great questions. Appreciate it. If you have any more questions, let me know. I'm going to be hanging out downstairs for a bit. I'm also pretty active on LinkedIn. Find me there. There are a lot of Himanshu Guptas on LinkedIn. It's a very common name. So search for Himanshu Gupta Solace, and you'll find me. Thank you for your questions. Appreciate it. Thank you.